Hey everyone. So if you're working with TypeScript, you already know you love that compile time safety net. It's awesome. But what happens when your app goes live? What happens at runtime when it has to deal with messy, unpredictable data from the real world? Well, that's exactly what we're going to dive into.
Think about it. You've spent all this time writing this beautiful, clean, strongly typed code. Everything lines up perfectly. But let me ask you a question. Are your types really safe? Because there's this little gap, a blind spot that a lot of us can miss, and it pops up the second your application actually starts running. And here it is. This is the blind spot. You know, TypeScript's type checking is like a super sturdy bridge you build before anyone drives on it. But once your code is running and data starts flowing in from an API or a user form, that bridge isn't there anymore. So your app might be expecting a user's name as a string, but the API sends back null. And what happens next? Yep, crash.
Okay, that sounds kind of scary, right? But don't worry, because this is where our hero of the day enters the picture. Meet Zod. It's a library designed specifically to be the runtime bodyguard for your data. And the best part? It's built with TypeScript in mind from the ground up, ready to stand guard right at the front door of your application.
So what is Zod really? Well, the best way to think about it is like a security guard for your data. You hand it a very specific guest list, which we call a schema, that describes exactly what kind of data is allowed into your app. Zod then takes every piece of incoming data and checks against that list, making sure it has the perfect shape and structure before it ever gets a chance to cause any trouble.
So why is Zod becoming so popular? Well, it boils down to a few key things. First, it's TypeScript-first, which means it plays perfectly with your existing code. Second, it gives us that crucial runtime validation we've been talking about. It also has a really rich ecosystem of features, but it's still incredibly simple and intuitive to use. And get this, it has zero external dependencies. That means it keeps your project light and clean.
All right, let's pop the hood and take a look at Zod's core superpowers. We're going to see how it lets you define what your data should look like, how it checks or parses that data, and how it can automatically infer your TypeScript types. Everything in Zod starts with a schema. Just look at this little snippet of code here. This is our guest list. It's just a plain object that clearly states, hey, I expect a name that's a string and an age that's a number. Oh, and by the way, that number better be at least 18. It's super readable for us humans, and it's perfectly enforceable by the machine. So once you have that schema, you need to actually validate your data with it. Zod gives you two main ways to do this. You've got .parse, which is very direct. If the data is good, it returns it. If it's bad, it throws an error. But then you have .safeParse, which is often the one you want. It never throws an error. Instead, it just returns a little object that tells you if it was successful, and then gives you either the clean data or a detailed error object. This makes handling bad data so much cleaner.
And this, right here, this is where the magic really happens. With just one simple line of code, z.infer, you can generate a static TypeScript type directly from your runtime schema. This is huge. It means you no longer have to maintain two separate definitions, one for your types and another for your validation rules. You define it once with Zod, and you get both, completely in sync, for free.
Okay, all this theory is great, but let's see Zod in the wild. Let's put it into action. In a really common scenario, building a completely type-safe form in a React application. As the folks at FreeCodeCamp put it, Zod and the super popular library React Hook Form are a dynamic duo. And it's totally true. When you put a powerful form management library together with a powerful validation library, you get this seamless, incredibly robust, and honestly a really enjoyable way to handle user input.
So how do you get these two to talk to each other? Well, there's a secret ingredient, a tiny utility called Zod Resolver. It's basically a little bridge that lets React Hook Form use your Zod schema as its rulebook. You just pass your schema into the resolver, and damn, the integration is done. It really is that simple. Now check out this more complex form schema. We've got built-in checks for things like emails and URLs. We can set a minimum length for a password, and for any custom logic, like checking if two password fields match, we can use this super powerful .refine method. The key here is that all of your form's validation logic now lives in one clean declarative object. So what does all that code get you? Well, for the end user, it means instant, helpful feedback. The entire validation process is driven by that one schema we just made, so you get these clear, helpful error messages right in the UI. It just makes for a much better user experience and stops bad data before it's even submitted.
But Zod's power doesn't stop on the client side. Validating on the front end is great for the user experience for sure. But what about the integrity of your data? What about security? For that, you absolutely need validation on the server. And guess what? Zod excels there too.
Let me be super clear about this. You should never, ever trust data that comes from the client. Ever. A savvy user can always bypass your front-end JavaScript. So server-side validation isn't optional. It's a fundamental security measure to make sure the data entering your system is safe and correct.
And just look how straightforward Zod makes this on the server. In your API route, you just receive the request, grab the data, and then run it through the exact same safe parse method we used on the client. If it passes, awesome. You can continue with your logic. If it fails, you just send back a nice structured error response. It's clean, safe, and totally predictable.
And this is the real game changer. You use the exact same schema on the server that you used on the client. You write it once, and then you can share it between your front end and back end. This creates a single source of truth for your data shape, which gets rid of so much duplicated code and prevents those annoying bugs that happen when your client and server rules get out of sync.
Okay, so let's zoom out and wrap this up. What's the big takeaway here? Why should you really consider bringing a tool like Zod into your next TypeScript project? Bottom line, Zod helps you build more resilient applications. It closes that loop we talked about, extending TypeScript's safety net from just compile time all the way through to runtime. It gives you that single source of truth for your data across your entire stack. Its API is honestly a joy to work with, and maybe most importantly, it just wipes out an entire class of common, frustrating runtime errors caused by unexpected data.
So I'll just leave you with this one question to think about. How much stronger, safer, and more reliable could your application be if you just adopted one simple principle? Never trust incoming data, and instead, let a guard like Zod validate it at the door. Thanks for tuning in.